I'll introduce Iván Solt. He's going to speak about, what are you going to talk about this time? Oh, good, Instant JChem.
You have no idea what I'm going to talk about. Okay, thank you, Richard, for this extremely nice introduction. What I'm going to talk about is actually not what is written here. Maybe it's a bit too much, I think. So the title says JChem for Excel and Instant JChem, but actually Peter talked a lot about Instant JChem, and after me comes Erin, who is going to talk even more about Instant JChem. So I thought that after all, even despite the title, I will be focusing more on JChem for Excel and Reactor and just skip the Instant JChem part. So also, you will not find these slides on the pen drive. The reason for that is that I have 4 slides altogether, including title slides and acknowledgements. The reason for that is that this is not going to be a presentation. This is going to be a live demo. So let me just switch to Excel and start right away. I assume that some of you are familiar with JChem for Excel already. Maybe even most of you are familiar with it. So I would probably skip the introduction to Excel. I would just tell a few words about it. Also, when I started to prepare myself for this presentation, I was thinking, why shall we talk about Excel in the first place? I mean, this is so simple, this is so straightforward. Most of us are familiar with Microsoft Office. Well, maybe the luckier ones are not, but still, so this is a very straightforward tool, and it's very easy to use. And then I recognized that actually this is why we should be talking about this, because this is really simple. So it can be a very simple solution for many problems, and I think we should point this out. Okay, so once you install JChem for Excel, you will get the integration of the ChemAxon technology into Microsoft Excel's environment. What you will get is an extra tab, a JChem tab, that offers you a collection of buttons through which you can access chemical functionality within Excel spreadsheets. So the most basic functionality probably that you would expect would be the ability to add and edit chemical structures to Excel. So let's go for it. Let's just draw a simple structure. Maybe a well-known friend. So that's quite simple. And actually, it can be even made more simple. The default sketcher that pops up is a Marvin sketch, in which you can access certain shortcuts, like functional group abbreviations, something like this, or element shortcuts, or other groups like this one. So it's pretty easy to draw with this. Or you can even use the name import. I could type just adrenaline here. Oops. And go for that. So drawing is pretty easy, but still you could say that I don't like Marvin sketch, and I would like to choose another sketcher that I'm more familiar with. So you can do that actually. You can go to options, which is not easy due to my resolution now, but yeah, I can select it here and go to structure editor. And instead of the Marvin.net, you could use ChemDraw or even IsisDraw. Well, I'm not going to do that now, but there's an option to do that. Okay, so this is just something very basic. Another basic functionality that you might want to expect is to have certain calculations or predictions. So you have a structure here, and you might want to know the log P, for instance, or the strongest acidic pKa value, or maybe a name for your structure. So the other extra that comes with the JChem for Excel integration is a collection of Excel functions that allow you to do all these calculations. Well, this is obviously just a highlight of what is available. If you look at the collection, you will see that there's a large collection of various calculations that you can do with structures within the Excel framework. So I just go for log P calculation here. I select the molecule on which I want to do that. Click OK. So there's a number that I was looking for. Same story with pKa. In this case, I'm going for the strongest acidic pKa, so I also need to add a number here that I want to go the strongest one. And just go for that. An IUPAC name can be calculated the same way. Right here. And as you're used to it in Excel, you can just expand this for the rest of the structures. So it's pretty straightforward. Now, all these calculations have relatively simple return values, but you can actually add more complex return values here. Let me just wrap this. For instance, an image that will show you the charge distribution on this structure by assigning point charges to the atoms. So just another Excel function here. There you go. And what you get is another structure representation with the point charges on it. Okay, so that's something really useful, but this is something that you would expect probably from an application like this. You have drawn structures, but the form of the input might be different in certain cases. You might get the input in form of strings, something like this, for instance. You can have common names. That's okay. You may have IUPAC names, or even SMILE strings, INCH strings, or a cast number. So a few versions ago, what you would have done would have been right-click on this, search for convert from text. Well, in this case, this is a name. Well, that's pretty annoying, so you want to avoid that. So due to a recent development, a recent improvement in Excel, you can just select this whole bunch of guys and convert them from the text representations to actual structural representations. But you might think, well, obviously, once you have the structures, then you can process them just like you did before. But you might still think that this is still too much. I don't want to do that. I want to deal with the original strings. So I want to add a calculation here, for instance, the log P, that goes on the string. There you go. So you can calculate the log P value of cast number. Yeah, whatever. But you can do that. So I think that this is a really elegant way to process chemical content in Excel spreadsheets. OK, so we have drawn structures. We have converted strings to structures, and vice versa. But what if I have the structures, but I just don't want to see them? I want to see some sort of string representations of them. Obviously, you can do that. One obvious choice would be sorry, to use the SMILE strings, because that's a unique string representation of the structure. So let's just do an experiment here. I insert an extra column. And I copy these structures here just to see their original orientations. And let's look at the original toSmiles function of Excel. Well, this is nice. This gives you back the SMILE string. And you can share this with your colleague. They can add their comments, send this back to you, whatever. And then you convert them back from SMILEs. And what you will see is that the orientations have changed. This is something that you might not like. Well, I wouldn't like it, personally. So once again, a relatively recent development allows you now to get embedded SMILEs, to embed the structures into the SMILEs representations, get the SMILE strings, but when you convert them back to actual structures, you will restore the original orientations and the original, well, in this case, distorted 2D coordinates. So, yeah, this is, like I said, a novel development, and I just wanted to point your attention to that. Okay. Right. The SMILES strings are a unique representation of your structures, that's true, but you might want to use some other unique representations, for instance, an in-house registration ID. That would be quite common. So once you have the structures here, I can remove this column now. By editing them, you can actually manually add an identifier to this structure. So this could be a default SMILE or a name of the molecule, but I could also add some identifier like ChemAxon 1, 2, 3, 4, 5. And now, if I have associated this identifier with the structure, I can just select to show the ID instead of the structure. I can do it here as well. And do the same. And convert them back to their structure representations. Yeah, this is very, very useful, really. But if I have 2,000 compounds, this is something I really don't want to do, to manually enter all these identifiers. So there's a way to come around this. Namely, if you have an SD file, for instance, and you have the registration IDs in that SD file as a string or other structure representation, you can select that field to be the identifier on the structure, and that will be added to the structure cell. So let's look at how that actually works live. So I'm going to import an SD file. Let's say this one. If I look at the columns, I see that there's a structure column and there's a compound registration ID column. So I can go to edit this field and select this field to be an identifier for my structure. So if I now click OK and go to import this file, what I will have here are two columns. Obviously, I will have both of them here, but I can select to hide this one. And here, instead of the structures, I can select to see the IDs only. Obviously, I can also convert it back. So practically, you can save extra columns in your spreadsheet. Now, this was a file import, but you can do the same thing for database import, actually. What I have done, I have prepared a small database of reagents in Instant JChem on a MySQL database. And I go back now to Excel and go to import one of these sets from this database. I have the connection here, and I'm going to import this table. Now, on import, I could carry out a search, searching any of the fields that are present in the database. I will not do this now because I want to import all the compounds. So in the next dialog field, I can select which fields I want to actually import from the database. This will be the structure and the registration ID. For the registration ID, I will once again do the same. Just like before, it's the same dialog. I will set it as an identifier for the structure. Now, this configuration for the field import can be saved in an XML file and can be reloaded later on when you import similar database tables. Okay, so I just do the search, this artificial search, which returns all the structures, select them all, and map them on my Excel spreadsheet. Right, so now I have two sets of compounds here. And I assume that you know where I'm going with this. These will be reactants. I cannot type.
Want me to help?
No. Richard, don't come close to my notebook, please. And I will have a set of products from these two reactants. Now, in order to do this, I will need Reactor. I'm not sure if you are familiar with Reactor or not. For the benefit of those who are not, just a few words about this. Reactor is a virtual reaction enumeration engine. What it does, it takes a set of reactants as input, and it tries to predict the chemically feasible products from these reactants. The prediction is based on a reaction scheme. A reaction scheme consists of a very generic reaction equation and a set of rules that determine the reactivity of the input reactants, the selectivity of the reaction itself, and it also takes care of the exclusion of those reactants which, under the given reaction condition, would undergo, for instance, alternative reaction pathways. Therefore, it is capable of predicting the synthetically available products from a set of input reactants. I hope this image tells you everything. Okay, so what I will do now is I will import a reaction equation, a generic reaction equation from a file. This will be an indole synthesis. I only need the structure here. There's the reaction itself. Yes. Right. So there you have the reaction itself. And this will be used as the basis for the reaction enumeration. Okay. The reactor can be used in Excel with another Excel function, just like you have seen it before. JCReact. Where the reaction is this one, and the two reactants are in these cells. So, of course, one more. I want to use the same reaction everywhere. So now I just double click here. And what I get is a sequential reaction enumeration in Excel. I will tell you later why I call this sequential. Okay. Time flies. I speed it up a little bit. I sent these compounds to synthesis. They have synthesized it, and they got back with analysis results. So what I get is a set of IC50 values for a subset of these compounds. Now, what I would like to know is actually how different the variable side chains around the methylindole backbone or scaffold are affecting the IC50 values. So what I could do for that would be an R group decomposition. So what I will do now is I will select these. No, first. I will convert these to SMI strings. Select these and copy them to a new sheet. This will be the structure. This will be IC50. Obviously, I convert this back. That's a convenient way to safely copy records. And I will do an R group decomposition on this. Scaffold could be this one. This is a methylindole derivative set. So I will run for these three variable side chains here. Okay, so I just run it. What I get as a result is an R group table on this set of compounds. So I know that R3 is almost the same everywhere. So my assumption is that, yeah, I really don't care about how that affects the IC50. What I really care about is how R1 and R2 affects it. So what I will do now is I will do a pivot table on this data set. Oops. Okay. It's not valid. I must have done something wrong. Okay, the name. I did something unexpected. Boo, boo, boo. Maybe. Right, thanks. Okay, I will include these because this is a common, yeah. And use the average. Yeah, what I forgot to do was to convert the structures to slice strings. Sorry about that. I was confused by this error. Anyway, I did it in advance to avoid these confusions, obviously. So what you could get is a pivot table like this, where you have the slice strings in the columns and the row headers. And after a little bit of formatting, you could get something like this, where you have the IC50 averages associated with the variable R groups. And you might want to do a report on this. So you might want to just copy this to a Word document. Now, there are multiple ways to do that. You could just copy-paste it. Well, this is nice, except for the structures are missing. So, yeah, this is a difficulty about Excel versus Word communication. So, what the developers have invented here is a new copy method, where you can copy and paste this content as a ChemAxon format, and then just paste it here as a ChemAxon format. And in that case, you will also have the structures in the headers and the fields associated with them. I'm not done yet. There is more. I have 2 more minutes. And guess what? Yeah, it's not trivial, actually. You can even conditional format this. And once again, if I go for it, this is another thing that is not trivial to transfer to Word. So in the original set, it wouldn't be transferred. Yeah, there you go. It's all empty. The conditional formatting hasn't gone through. So there's another option that you need to be aware of. If you work with this in Excel, namely, you can select either to transfer the conditional formatting on the clipboard or not to do that. So now if I try to do that, it should work. There you go.
John, you need to clap again.
Yeah, well, I would have more to say, but unfortunately my time is almost up, as Richard very politely put a 10 by 10 centimeter clock in front of me. So I think I finish it here. The last thing that I wanted to show you is my last slide. Are the people who actually worked hard on these products, on the JChem for Excel side and on the Reactor side. The leader of these development groups are Viktor Hámori on the JChem for Excel side and Zsolt Mohácsi for Reactor. So thank them and ask me questions. Thank you for your attention.
Does it run on a Mac?
Any other question? No, unfortunately not. It doesn't. Except if your Mac is running on Windows 7 or 8. No, and unfortunately, the Excel or the Office version for the Mac is totally different in architecture. So that would be a different product if we wanted to have it running on Mac. So that would be a different development.
Any plans? Maybe someday?
Yeah. Just a sec. Yeah, Victor, can you comment on that? I'm not sure about the plans in this direction, but I wouldn't promise anything now.
We get the same questions on Open Office, and I think it's a market share thing. I know there's more Mac users than there have in the past, but this is an entirely different bird to program. And so
Yeah.
and I'm a Mac user, so I feel your pain.
How about 64-bit?
Yes. That's probably easier than Mac.
What would happen if you exported the column that had the chemical structure with the registry number associated with it and put that into some other application? Would you be able to still to toggle back and forth?
No, it's done by an Excel function as far as I know, but on this, I think Victor could comment on that. In a totally different application, I don't think you could toggle back and forth, no.
Okay. You did a good job despite the bad introduction. Thank you.
Thanks, Richard.